Okay, consider the two planes x plus 3y minus 2z equals 7 and 2x plus y minus 3z equals 0 in R3. Which of the following sets is the intersection of these planes? The intersection should be between two planes, unless they're the same plane, which I doubt, should be a line, which is 1 degree of freedom. Unless they don't intersect at all, in which case they're parallel. They've got to be parallel. But they're not parallel, because the respective slopes aren't equal. So we automatically rule out A. And their planes, if they're intersecting at all, they've got to intersect in a line. They can't intersect at a point. So we rule out B. And E is describing a plane. So if these two planes intersect, they can't intersect in a plane unless they're the same plane. And this is not the same plane. So we can rule out E. So it's either C or D, which makes sense since it's 1 degree of freedom. But which one is it? If we write the equations as a system, we get x plus 3y minus 2z equals 7, x plus 3y minus 2z equals 7, and 2x plus y minus 3z. 2x plus y minus 3z equals 0. We can solve for this. At least we can solve for the degree of freedom. Okay, I'm gonna subtract 3 times the bottom one from the top one. So we get minus 5x plus 0y. 9 minus 2 is 7z. And this equals 7. So that tells us that 7 times z minus 1 over 5 equals x. How do we get the other degree of freedom? So if we have x equals t, then 5/7 x plus 1 equals z. So z equals 5/7 t plus 1. And, oh, to get the other one, of course, we subtract it a different way. We take 2/3. No, subtract. We subtract that because the negatives cancel. We subtract 2/3 times this, and what we end up getting is negative 4 4/3 plus 1 is negative 1/3 x, and then minus 3 minus 2/3 is 7/3, and then that the z's go away. And this is 7, so that tells us that we have negative x plus 7y equals 21. So 7y minus 21 equals x, and we get y equals 7. No, we need it in terms of y. So 21 plus x over 7, which equals 3 plus 1/7 x. So y equals 3 plus 1/7 t. And what do we get? If we multiply this by 7, we get x equals 7t, z equals 5t plus 7, and y equals t plus 21. Oh, of course. If we replace t with... We're not multiplying the whole thing by 7. We're just multiplying the t by 7. So it becomes z equals 5t plus 1, and y equals t plus 3, which is what we get here. So the answer is D.